Dear students, welcome to Easy BTech, your guide for BTech and beyond. So Easy BTech helps the students to learn the concepts of engineering subjects in an easiest way, and they can prepare well for the examinations and score more marks. So in the previous lecture of engineering mechanics, so I taught about the resultant of a force system and parallelogram law of forces. So in this video, I explain you about the resultant of a force system. As I already taught you, the resultant is a single force which produces the same effect as that of a number of forces. So if a body is taken, let us say, so the F1 is one force and F2 is another force here, and F3 is one more force is acting here, and F4 is another force. So this can be replaced by a single force, so which is nothing but the resultant. So the resultant force is also given with the magnitude as well as the direction. So now I told you that finding the resultant of a force system is known as the composition. So composition of a force system means finding the resultant of the given forces. And similarly, if a force is divided into its components, it is known as the resolution of a force. So to find the resultant of the given forces, important thing here is we need to find the resolution of a force. So the composition means if more number of forces are there, it is replaced by a single force which produces the same effect. Whereas the resolution of a force means dividing a force into its components. So in the two-dimensional force system, F is divided into two components, Fx and Fy. So whereas in three-dimensional system, the force is divided into three components, Fx and Fy and Fz. So to find the resultant of the given force system, the most important thing is we need to know about the resolution of a force. And how to find the components of a force. So here, if you're taken a coplanar concurrent force system, so let us say that this one is X and this is Y. So this is two-dimensional one here, and in this one, so the direction towards right is plus and direction towards left is taken as minus, and the upward direction is taken as plus, and downward direction along y-axis is taken as the minus one. So in the first one here, so if a force is acting along the x-axis, if the force is acting along x-axis towards right, so Fx is equal to F. So this is a magnitude and direction is plus here because it is acting towards right. And the same force is acting along x-axis towards left. Then so here the y component will be equal to 0. And similarly, if the force is acting on x-axis towards left here, so the Fx is equal to minus F. Fx is equal to minus F. And Fy is equal to 0. And now, if a force is acting along y-axis, so this is the third one, and so in such a case, the x component becomes 0 and y component becomes F. Because it is acting in the upward direction, so this becomes plus. And fourth one is, if a force is acting along y direction in the downward one, so then let us say this is the F. So then Fx is equal to 0 and Fy is equal to F. But the direction is minus here because it is acting in the downward direction. And now we see that if a force is acting in xy plane at an angle theta. So at an angle theta, okay, this is making an angle theta with so this x-axis. So now the fx is equal to f cos theta and fy is equal to f sin theta. Okay, so if a force is acting at an angle theta, so in this first quadrant here, fx is equal to f cos theta and fy is equal to f sin theta. So this is important. First you need to check whether f is making angle with x or y. Because this is making angle with x, the x component becomes f cos theta and y component becomes f sin theta. And in this case, you should remember one thing, while taking the direction, so x towards right is plus and y, okay, in the upward direction is plus. So these values both are positive. And now, so you consider one more force. Let us say this force is F2 and it is making an angle theta with x-axis. So in this particular case, so Fx is f cos theta because this is making angle theta with x, and Fy is equal to f sin theta. So this is similar to the previous one. The only difference here is because it is making an angle with x towards left here, this becomes minus, and whereas the y component will become plus. So this is minus and this one is plus. And the third case here, if a force is acting in this third quadrant here, F, and this one is minus, and y is also minus here, and it is making an angle theta with the x-axis. Let us say this force is F3. Now, the F3x is equal to F3 cos theta, and F3y is equal to F3 sin theta. So when it comes to the direction, because here the x component is towards left and y component is acting in the downward direction, so both are taken as minus here. Both are taken as minus. This is important. The first thing you need to identify is whether the force is making angle theta with x or y. So when it is making an angle theta with the x-axis, fx will become f cos theta, fy will become f sin theta. So based upon the sign convention, the force is acting in the first quadrant, so both will become positive. In the second case, the force is acting in the second quadrant here, and it is making angle theta with the x-axis. Fx is equal to f cos theta, fy is equal to f sin theta. Because x component is towards left, so this is minus f cos theta, whereas the y component is acting in the upward direction, so this becomes f sin theta. And the third one here is the force is acting in the third quadrant here, on the same xy plane here, and now it is making an angle theta with x-axis. F3x is equal to F3 cos theta, F3y is equal to F3 sin theta here, but both are minus. Now you take one more case on the same xy plane here. If a force F4 is making an angle theta with x-axis and it is acting in the fourth quadrant, then this Fx is equal to F4 cos theta. I told you already from the basics of trigonometry, because this is making angle theta with the x-axis here, so this is Fx is equal to F4 cos theta, and Fy is equal to F4 sin theta. So when it comes to the direction here, and this one is positive, x component, and y component is minus. So this is plus and this one is minus. So the another thing is, we see that if a force is making angle with the y-axis, the force Fy is making angle theta with y-axis, then this F5x and F5y. So how the components can be calculated? So because this is adjacent to y-axis, so F5y becomes F5 cos theta, and this one will become F5 sin theta. So in this particular case, so the x component is acting towards right, it is plus, and y component is acting in the upward direction, it is also plus. So the both values are positive. So in this way, we can find the components of a given force. So we should identify with which axis the angle theta is given, and we should write what is x component and what is y component. And if you're taken a force, let us say this is F6 and it is making angle theta with y. Then what is F6x and F6y? So in such a case, because it is making angle theta with F6 here and it is adjacent to y-axis, so this becomes F6 cos theta and this one is F6 sin theta. Now, when it comes to the direction, the x component becomes minus and y component becomes plus. So this is minus and this one is plus. And one more thing here is, let us say in the same planar system, if one more force is taken, F7, and it is making angle theta with y. So in such a case, so first you see that whether it is making angle with x-axis or y-axis, then you can write x component as well as y component. So when it comes to the y component here, F7y, this becomes F7 cos theta. From trigonometry, we know that the cos theta is equal to the adjacent side by hypotenuse. So F7 will become F7 sin theta. So in such a case, the x component becomes positive and y components becomes negative. So this is plus and this one is minus. And one more thing here is, let us say if a force F8 is taken here, and now let us say it is making angle theta with y, then this F8x becomes F8 sin theta and F8y becomes F8 cos theta. And you take one more force here. Let us say one force F9 is acting in the fourth quadrant and it makes angle theta with y. So F9x and F9y. Because it is making angle theta with y, this becomes F9 cos theta and this becomes F9 sin theta. F9 sin theta. And here the x component is plus and y component is minus. So you need a very good practice at the beginning to find the components of a given force. Finding the components of a given force is known as a resolution of a force. Here force is actually resolved into its components along two axes which are perpendicular to each other. And now we combine all these things in one diagram. So let us say this one is F1 and this is F2 and this one is F3 and this is F4 and this force is F5 and this one is F6 and this one is F7 and this force is F8. So now F2 is making an angle theta 1 with x-axis here and F4 is making an angle theta 2 with y and F5 is making an angle theta 3 with x-axis, and F8 is making an angle theta 4 with y-axis. So for this combined one, so this represents the coplanar force system, and all the forces are meeting at one point. Let us say this is O, and all these forces are meeting at one point. So this is known as concurrent system. So this represents the coplanar concurrent force system. So in such a case, now you write x and y components of each force in a tabular form. So let us say this is F and Fx, and this one is Fy. So here, if you take an F1, because F1 is acting along x-axis here, the x component is F1 and y component is 0. And here we take the sign convention like this. Along x-axis, the force towards right is plus and force towards left is minus. On y-axis, force in the upward direction is plus, force in the downward direction is minus. So this is the sign convention we follow in doing the problems related to the resultant. Now F1 is making, now it is acting along the x-axis. So the x component becomes F1 and y component becomes 0. And when it comes to the F2 force here, it is making an angle theta 1 with x-axis. I told you, because this is adjacent to F1, so here the F2x becomes F2 cos theta 1, F2y becomes F2 sin theta 1. And when you're taking the F3 force here, F3 is acting along y-axis in the upward direction. Its x component is 0 and y component is F3. And similarly, if you're taking the F4 here, it is making an angle theta 2 with the y-axis. So the y component becomes F4 cos theta 2, x component becomes F4 sin theta 2. And F5 is acting along x-axis towards left here. So the x component is F5 minus F5 and y component is 0. And when it comes to the F6 here, it is making an angle theta 3 with the x-axis here. So x component becomes F6 cos theta 3 and y component becomes F6 sin theta 3. And F7 is the force here. It is acting along y-axis in the downward direction here. So the x component is 0 and the y component is minus F7 because it is acting in the downward direction. And whereas F8 force is making an angle theta 4 with y. Because it is making angle theta 4 with y, the y component becomes F8 cos theta 4. So, but it is acting in the downward direction. So minus F8 cos theta 4. And x component is F8 sin theta 4, but it is positive. So this way we can write the x and y components of a coplanar concurrent force system. So now, so we write all these forces and its components in a tabular format. So here, let us say if you take an F1, as I told you, this becomes F1 and this is plus and y component is 0. And when it comes to F2, x component is F2 cos theta 1 and this one is F2 sin theta 1. So when it comes to direction, so both are positive. And the next one is F3 and x component is 0, y component is F3, but this is plus. Then F4, so it is making angle theta 2 with y. So F4 cos theta 2. So this one is minus. So this direction is plus because it is acting in the upward direction. And so this is F4 sine theta 2, and it is acting towards left, so this one is minus. And F5, so x component is F1 and y component is 0, but it is minus F5. And F6, so you extend this table, so F6 is making angle theta 3 with x-axis, so F6 cos theta 3, and this one is F6 sine theta 3. But both are minus here, so this one is minus and this one is also minus. And when it comes to F7, so here if I take an F7, so F7 x component is 0 and y component is F7. And another one is F8. It is making an angle theta 4 with y. So x component will become F8 cos theta 4, and whereas x component is F8 sine theta 4. So in this one, the x component is plus and y component is minus.